Welcome to YQ Academy Collections Framework Java Interview Questions and Answers. 1. Explain about map interface in Java. The map interface represents a collection of key-value pairs, where each key is unique and maps to a corresponding value. It is part of the Java Collections Framework and provides a way to store and manipulate data based on key-value associations. While keys must be unique, the values in a map can be duplicated. Different keys can map to the same value. You can iterate over the key-value pairs in a map using various methods such as keyset, entryset, or values. These methods return collections or sets of keys, entries, or values, respectively, that you can use for iteration. 2. What is Linked HashMap and its features? Linked HashMap is an implementation of the map interface in Java that maintains the insertion order of its elements. It is similar to HashMap but provides additional features related to ordering. Features of Linked HashMap. 1. Ordered insertion. Linked HashMap maintains the order in which the elements are inserted into the map. When iterating over the map or retrieving the keys, entries, or values, they are returned in the same order as they were inserted. 2. Hash-based lookup. Like HashMap, Linked HashMap uses a hash table for efficient key-value lookup. It provides constant time performance for basic operations such as get, put, and remove. 3. Unique keys. Similar to other map implementations, Linked HashMap requires keys to be unique. If you attempt to insert a duplicate key, the existing key-value pair is updated with the new value. 4. Null values and keys. Linked HashMap allows null values and a single null key. You can store a null value and associate it with a null key. 5. Iteration order. The iteration order of Linked HashMap can be either in the order of insertion order or in the order of access order. By default, it uses the insertion order, but you can create a Linked HashMap with access order by passing a special constructor argument. 6. Iteration performance. Iterating over a Linked HashMap is more efficient than iterating over a tree map because it does not involve the overhead of maintaining a sorted order. Therefore, Linked HashMap is a good choice when you need both the ordering and efficient iteration. 3. What is SortedMap interface? The SortedMap interface in Java is a subtype of the map interface that represents a collection of key-value pairs where the keys are sorted in a particular order. It provides methods for accessing, manipulating, and navigating the elements based on their keys. Key features of SortedMap interface. 1. Sorted order. A sorted map maintains the keys in sorted order. The sorting is typically based on the natural order of the keys, or a custom comparator can be provided to define the sorting logic. 2. Key-value pairs. Like other map implementations, SortedMap stores elements as key-value pairs. Each key in the sorted map must be unique, and it can be associated with a corresponding value. 3. Navigation. SortedMap provides methods for navigating through the elements based on their keys. You can obtain the first and last keys, retrieve the next or previous key relative to a given key, and retrieve a submap of elements within a specified key range. 4. Search operations. SortedMap offers methods for searching elements based on their keys. You can find the first key that is greater than or equal to a specified key, or the last key that is less than or equal to a specified key. 5. Range views. SortedMap allows you to obtain submaps that are restricted to a certain key range. These sub-maps retain the sorted order of the original map and can be useful for extracting a specific range of elements. 4. What is HashTable and explain features of HashTable. HashTable is a legacy class in Java that implements the map interface and represents a collection of key-value pairs. It is similar to HashMap but is synchronized, which means it is thread-safe and can be safely used in multi-threaded environments. Key features of HashTable. 1. Key-value mapping. HashTable stores data as key-value pairs. Each key in the HashTable must be unique, and it can be associated with a corresponding value. Both the key and value can be of any non-null reference type. 2. Synchronization. HashTable is synchronized, which means it provides thread-safe operations. This makes HashTable suitable for use in concurrent environments where multiple threads may access or modify the HashTable simultaneously. The synchronization ensures that the internal state of the HashTable is properly maintained during concurrent access. 3. Hashing and lookup. HashTable uses a hashing technique to store and retrieve elements based on their keys. It internally maintains an array of buckets, and each bucket can contain multiple key-value pairs. The hash code of the key is used to determine the bucket where the key-value pair should be stored, and the equals method is used to find the exact match within the bucket. 4. Null keys and values. HashTable does not allow null keys or values. If you try to insert a null key or value, a null pointer exception will be thrown. All keys and values must be non-null. 5. Enumeration. HashTable provides an enumeration interface to iterate over its elements. The elements are returned in no specific order. The enumeration interface has methods like hasMoreElements and nextElement to iterate through the elements. 6. Legacy class. HashTable is a legacy class and has been largely replaced by the HashMap class, which offers similar functionality but without the synchronization overhead. It is recommended to use HashMap or concurrent HashMap for new applications unless synchronization is explicitly required. 5. Difference between HashMap and HashTable. 1. Synchronization. HashTable is synchronized, which means it is thread-safe and can be safely used in multi-threaded environments. Multiple threads can access and modify a HashTable concurrently without causing data inconsistency. On the other hand, HashMap is not synchronized by default. If multiple threads access a HashMap concurrently and modify its contents, it may result in an inconsistent state. However, you can make a HashMap thread safe by using the concurrent HashMap class or by explicitly synchronizing access to the HashMap. 2. Null keys and values. HashTable does not allow null keys or values. If you try to insert a null key or value into a HashTable, a null pointer exception will be thrown. HashMap, on the other hand, allows one null key and multiple null values. You can insert a null key and retrieve it using the get method. HashMap also allows multiple null values to be associated with different keys. 3. Iteration order. The iteration order of HashMap is not guaranteed and may change over time, especially if the HashMap is modified. HashTable, on the other hand, maintains the insertion order of its elements during iteration. If you need a specific order of iteration, you can use the Linked HashMap class, which maintains the order of elements based on insertion or access order. 4. Performance. HashMap is generally considered more efficient in terms of performance compared to HashTable. Since HashMap is not synchronized by default, it incurs less overhead related to thread safety. In scenarios where synchronization is not required, using HashMap can provide better performance. However, if thread safety is a requirement, HashTable can be a suitable choice. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.